Hello class, this is Mr. Eggleston, and this is lesson 8.6 for Algebra 1, Interpreting Models for Exponential Growth and Decay. There are only two learning targets for this lesson. The first learning target is how to interpret the parameters of an exponential function in terms of its context. In other words, we're going to read a problem, and then from that statement that we read, we will figure out what the initial amount is and how to calculate the common ratio, what we're multiplying by. All right? And then we're going to learn how to use exponential models to make predictions, which is what we oftentimes use them for, these models, what we do in math, is to make predictions about future events or future values. All right, so let's begin this. It's talking about the U.S. Census data can be used to track which cities in the U.S. are growing the fastest. The city of Buckeye, Arizona, has been on the list of fastest growing cities for several years due to its excellent winter weather. Notice it's winter weather, not summer weather. I'm pretty sure summer weather is going to be pretty darn hot. Okay, its proximity to the job market of Phoenix and convenient access to many outdoor activities. All right? And then in 2010, that's an important number to remember. The population in Buckeye, Arizona was 50,876 people. That was given to you. It is estimated that the city's population grows by about 6.5% annually. All right? So approximate Buckeye's population in 2011. Well, that would just be the amount, the population in 2010, which was given as 50,876, plus the change. And they said it grows at a 6.5% annually. So that would be, again, 50,876 now multiplied by 6.5%, which is written in decimal form as 0.065. Make sure you understand how to turn basic numbers like 6.5% into a decimal. Percent means per 100. Which means you take the number 6.5 and divide it by 100, and that's how you find the decimal, and so that's going to be 0.065. 0.065. And if you, okay, so this is original, and this is amount added. So we plug into our calculators. I'm just going to do it on decimals because by now you should know how to do it on your basic calculator. So I'm just going to do this. And it's going to be, because I'm just using the calculator, not trying to graph, it's going to be 50,876 plus 50,876 times 0.065. And that gives us 54,182.94 people. Now, we cannot have a 0.94 of a person. Either you have a whole person or you don't. So 0.94, we're just going to round that up to the nearest whole number, and that's going to be 5,408, I can't even speak, 54,183 people. Okay? So, now, What is the difference in population between 2011 and 2010? Well, we would just take 54,183 minus the original amount of 50,876, and that would give us 3,307 people. How many times greater was the 2011 population than the 2010 population? All right, so what we would do is take the 54,183, that's the 2011 population, and divide it by the 2010 population of 50,876. And that gives us, if you do the calculation, 1.065. Okay? Now, complete the table. So what is this? Okay, this means it's 1.065 is 6.5% growth. Notice the 1, because right here, I guess I should back up. Right here, it was 5,876. And then if we factor that out, we got here and here. So then we are left with 1 plus 0.065. All right. This is the growth factor. Okay, it's 1 plus 0.065 because it's growing. If we were losing 6.5% each year, it would be 1 minus. That's a key concept. All right. So this is our growth factor. So to go from 50,876 down to the next one, we already got the 2011. It was 54,183. And then to go to the next year, we'll just multiply by the growth factor again of 1.065. And if you do that, it would be 57,704 personas. And if we, again, so to do this, we are multiplying by the growth factor, 1.065 each time. And so this one will be it will literally be 61,456. And again, we're multiplying it by the growth factor of 1.065. All right. Now, notice we skip from 2013 to 2022. How many years is that? So each one of these is 1 year, right? Each one is plus 1, plus 1, plus 1. Now, all of a sudden, we jump from 2013 to 2022. That's plus 9. So now we would take 61,456 and now multiply it by the growth factor of 1.065, and we would do it 9 times. There's a shorter way of writing this than this, okay, because I'd have to write out 9 of them. But really, since we're repeatedly multiplying by 1.065, we can write this as 1.065 to the 9th power. And if you use your calculator, you would see that this equals, to the nearest whole person, 108,000. 320, and this whole thing needs to be shifted down one row. I did in the wrong row. All right. So it should be right there. Okay. So that's how you can do this exponential growth. So does the population of Buckeye, Arizona follow a linear pattern or an exponential pattern? How do you know? It's definitely exponential. Okay, because we are multiplying by a constant term, which we call the common ratio. We're multiplying by 1.065 from year to year. So now it says write an equation for P of T, the population of the Buckeye, Arizona, T years after 2010. So T in this is years after 2010. Okay. So that would be the population P of T would equal the initial population of, what was it again? It was 5,876 times the growth factor of 1.065 to the T power. Now, if you wanted the population 2020, you'd have to figure out that 2020 is 10 years after 2010, so T would be 10. Remember, T is years after 2010, so be aware of that, because if you put in like 2020 in for T, you're going to get a huge number that won't make sense, that could not live comfortably on the earth together. All right? Okay, question 7. St. Louis, Missouri has seen the decline. Now, see, whereas one was growing, the other one is a decline in their population by about 2% per year. If this is the case, what do you expect to be the value of the quotient St. Louis's population in 2020 divided by St. Louis's population in 2021? Well, if it's decreasing by about 2% per year, so 2% decrease means you would have 100 minus 2, which is 98% left of the original amount. So this is 0.98. Okay. Now, when we get this, that's the percent that's left over. Okay. So it would be 98% remains. So, if the population, pop, goes down by 2%, then 98% remains. I wrote it above of the 2021 population.
Hello. I'm just checking to see if there's TVs in the classroom.
Okay. Population. Okay, so what you should get from this is that decrease by 2% means we keep 98% of the previous population. Okay? So there you go. Now let's go over the learning targets or the quick notes. The idea here is that exponential growth and decay is often given as a percent. You must turn that into a decimal. So you want to write as a decimal. To find growth decay factor, write percent as a decimal. This is the growth or decay rate. And then exponential growth will be 1 plus r. Notice it's greater. It's a plus. Means greater than 1. And if it's exponential decay, it would be 1 minus. Minus means less than 1. So when the base is greater than 1, that's growth. When the base is less than 1, that's decay. Okay? And there you go. Have a good day.